All right, let's just jump right into it. What we're talking about today isn't just some small upgrade for prosthetics. No, this is a complete reinvention of what it means to have one. I want you to imagine a technology that doesn't just let you control an artificial limb, but makes you feel it, as if you'd grown it yourself.
So to really get your head around how big a deal this is, look at this comparison. Today's tech, the current brain-computer interfaces, or BCIs, they feel like you're playing a video game. You're at a distance, controlling something on a screen. It's indirect, it's clumsy. The Neuro Photonic Agency, or NPX architecture, promises something else entirely. It's like your brain literally grows a new connection, making the prosthetic a seamless, intuitive, and immediate part of you.
So why do current systems feel so clunky and disconnected? Well, it all comes down to what's called the digital bottleneck. Think about it. Your brain is this incredibly complex analog computer. But our machines, they speak in ones and zeros. So to connect them, we have to take the rich, nuanced movie of our thoughts and intentions and chop it up, squeezing it through the tiny straw of binary code. Almost everything gets lost in translation.
And this quote just nails it. Current BCI tech doesn't really expand our minds, it just gives us, a faster typewriter. It's a slight improvement, sure, but it's not a revolution. The whole point of the MPAX architecture is to be that revolution by getting rid of that digital middleman altogether. So, how in the world does it work? Let's start with the journey out, from your thought to the prosthetics action. Now, the first huge problem you have to solve is neural noise. Your brain is firing off signals constantly, so how does the system possibly know which thought is a real command and which one is just random background chatter? The solution is this incredibly elegant biological lock and key. It's like a safety catch. When you form a real intention, like I want to pick up that cup, your neurons release a specific neurotransmitter, glutamate. An enzyme layer on the implant instantly converts that into, of all things, hydrogen peroxide. And that peroxide acts like a chemical password, flipping a switch on a special crystal, opening the gate, and letting the command go through. Any accidental thought just doesn't produce enough glutamate, so the gate stays locked. Simple as that. And right here, you can actually see that whole process in action. The glutamate comes in from the top, gets turned into peroxide, which then seeps through to this special crystal at the bottom, a tin perovskite. When it hits that crystal, it changes its electrical state from off to on. That action is what fires off a single particle of light, a photon, that carries your command forward into the next stage. Okay, so the command is real, the gate is open. But moving a complex robotic hand requires a ton of math, right? Well, instead of sending that signal out to some computer, which would create a delay, the NPX does all the calculation right there, inside the implant, and it does it literally at the speed of light. How fast is that? The calculation takes about 10 femtoseconds. That is 10 quadrillions of a second. I mean, to put that into perspective, in the time it takes light to just cross this tiny crystal, your super fast gaming computer hasn't even begun its first thought. The delay, the latency, it's effectively zero. And here's the real kicker. This mind-bendingly fast computation, it uses zero power. None. All the math, all the logic is physically etched into the structure of the crystal itself. The calculation is just a passive thing that happens as light passes through it, almost like light passing through a really, really smart lens. The energy was spent once when they made the thing. So let's take a look at how this is even possible. This is the processor, the diffractive optical neural network. Your simple command, like GRAST, enters as a single point of light on the left. As it travels through these complex layers etched into the crystal, the light waves just naturally bend and interfere with each other. And that physical process, that is the calculation. The light then focuses itself on a single point on the detector at the other side, and the location of that point is the answer, the complex, precise instructions for the prosthetic hand. Okay, so we've got instantaneous, totally silent, noise-free control. That is incredible. But honestly, that's only half the story. The real magic, the part that turns this from just a tool into a living organ, is the journey back in. It's about restoring the sense of touch. This is the question, right? This is what it all comes down to. Because if you can't feel what the prosthetic is doing, it's always going to feel alien, like something you're just operating. So how does the NPAX solve this? How does it make you feel the pressure of a handshake? Well, the answer is another beautiful, light-based system. Sensors on the prosthetic hand turn physical data, like pressure or texture, into pulses of light. That light shoots back up a fiber optic cable into the implant. Now, as you can see here, that light hits a detector, which creates a tiny electric current. This current then creates an electric field that gently nudges the neuron right next to it, using a process called capacitive coupling. The important part is it influences the neuron without ever physically touching it. It's a completely clean, safe, non-contact way to talk directly to the brain. And this is where it gets really profound. Think about how your brain processes this signal. Since the information didn't come through your skin or your eyes, your brain doesn't flag it as external data. Instead, it interprets it as what's called endogenous insight. It feels like an internal feeling, like a memory or a proprioception, that sense of where your body is in space. You don't think the hand is touching something, you simply feel it. And that right there is the end result. The line in the sand between your biological self and the synthetic hardware, it just disappears. The whole loop is so fast and so direct that in your own mind, the prosthetic becomes a true feeling part of you. So when you put all these incredible pieces together, that chemical gate for true intent, the light speed optical math, and that direct sensory feedback, what you get is a system that marks a monumental shift in what's possible for human-machine integration. This slide really says it all. The old way is a conscious, separate act. I command the claw to close. It's slow and there's no feeling. The NPX way is embodied. It's intuitive. I am closing my hand. The delay is gone, the sensation is real, and the I now includes the machine. And the future potential here is just staggering. Because all of this is done with light, you can scale the system up just by using different colors or wavelengths. You could have one color of light handling fine motor control going out, while another color is bringing texture feedback coming in, and maybe a third is running an internal loop for memory retrieval, all at the same time in the same crystal, with zero interference. And that brings us to the final thought to leave you with. We spend so much time talking about artificial intelligence. This technology kind of flips the script. It's not about creating an artificial agency. It's about creating an augmented human agency. So the real question is, if we remove the digital bottleneck between our minds and the world of information, what happens next? What will a human, thinking at the speed of light, choose to build?